Hello and welcome to another tutorial. So this time we are going to be continuing to extend our terrain helper tool. So we're going to be adding in support with the mesh export, being able to control the resolution that exports at, so that we could export our terrain at a higher or lower resolution as we need. We're going to make it a little bit easier for generating the texture with that, so supporting hiding game objects that are children of the terrain. And we'll also have a look at being able to export the alpha maps or the splat maps for the terrain, just so we've got some support for that. So let's dive on in to our code. So the first thing that we're going to need to do is we're going to need to update for our mesh export. I want to set up an enum to control the resolution that this gets exported at. Now, something with this is the texture resolution is not the same as the actual mesh resolution in terms of the number of vertices. So what I'm going to do is I'm going to have mesh export resolution. And with that, one of the things that I want to have by default is I want it to be able to match the height map. So that is going to be the default one, which will be 0. Then I want to have a resolution. Now, this is where the numbers are always going to be 1 above a power of 2. So we'll have 33 by 33, should like of that, and then it's doing its best autocomplete in terms of what it's trying to guess, but admittedly this is quite a bit different to what it would be expecting. So it'll be kind of interesting to see if by the end of this how it goes with picking up on the pattern. It is a more complex pattern, and it's trying. Let's give it a shot. So I want to support essentially all of the resolutions that you can use for the height maps. So that means everything from 33 by 33 all the way up to the 4097 by 4097. So I want to support that full range of ones. There's probably not a great deal of point supporting higher ones, but if we wanted to, it would be a matter of just adding in that additional entry into the enum here. That's why I'm going for this approach of making it that the actual value of the enum can be cast to an integer and give us the particular value that we need. So it just makes it a lot easier with structuring that for supporting other ones in future. It's just a single line rather than needing to rework a whole bunch of other sections of code. So it makes our life a lot easier. So 497. And it's getting better with the auto-completion. So there we go. We've got our set of ones in here. Now there's going to be our couple little bits of variables that we set up. So we're going to create those here as well. So I'll have mesh export resolution, terrain tool, mesh resolution, and I'll default that to matching the height map. And if we remember, we have our reset code here. So I just want to put that in to the reset code, just so we're making sure we're doing that. I'm also going to do a little bit of sort of cleaning up here of this, because we've got our stuff for selecting the terrain, and then we've got our height map tools. So I'm going to actually put in a couple of separators here. So edit a GUI layout, just chuck in a separator. And just because we're getting enough sort of complexity here, I'm going to actually have on GUI, and we'll call this mesh tools, mesh conversion tools. So just split that out. This will just make it so that our logic is a little bit cleaner, because we do currently have things where it will just make it a little bit neater. And this is something where don't be afraid to refactor code to clean things up a bit. So in this case, this convert to mesh, I would take that and bring that down to here. Just starts to make our code a little bit easier to navigate, means all of the height map ones are in the height map function, and means that we can have the stuff nicely grouped after it. So it just keeps it cleaner, neater, makes it easier to navigate. So I'm a big believer in regularly going and refactoring code. And in particular during sort of development, finding opportunities for quick sort of simple little bits of refactoring just to make it a bit easier. So the other thing I'm going to do is, because we're saving out a file here, potentially to the asset database, well, to the asset folder, I'm going to do an asset database refresh here, just so if we have saved something into the asset folder, it will pick that up. So our mesh conversion then, we've set up so we've got support for that enum. We're not actually using it yet, but what we can do is we can, similar to what we did with the texture resolution, it'll be terrain tool, mesh resolution, and then we cast it to that mesh export resolution. We do our editor, GUI layout, enum pop-up, mesh resolution, and then we just provide that same variable in there. So that's good. Now I'll pass that in here so that we are into our export, providing the mesh resolution as well. And so that's going to have this. Just need to make sure we use the mesh export resolution. So that's good. We've got our mesh export or mesh resolution now being passed into this. Now, what we want to do is we want to try and make it so that this is able to handle different resolutions as easily as possible. Now, at the moment, most things in this are actually already pretty good for handling it. It's largely down to this generation code here for populating this stuff. So the actual generation of these vertices, UV coordinates, indices, stuff like of that. So what I want to do is I actually want to change this so that what we have ends up being something that looks more like this. So again, this is a case of writing how I want to be able to use it before implementing it. So it's something like this, where from the actual code's point of view, we have these three variables, and we can go convert height map to mesh. We give it our terrain. We give it our mesh resolution. And then these vertices UV coordinates, and autocomplete's done a very nice job with that. So I want to be able to do like of that. And so this here whole block essentially will move into, because the rest of this code doesn't care about the size of those. It handles all of that itself completely fine. So that just means I need my convert height map to mesh, and that gets my terrain, and that's our target terrain. Gets a mesh export resolution, and then we have an out, and I'll do this on another line so it's easy to see. An out vector 3, that's the vertices. We have an out vector 2, pretty decent guess for guessing normals. In plenty of cases that would be the correct thing, but in our case it's the UV coordinates. And then an out int triangle indices. So we want that as the function, and then what I will do is I will take all of this code. This code is roughly what I want, and I will bring that up to here. But with this, I don't need to create those like that. I'm not creating new variables. So that code still compiles without any errors, which is good. And then I want to look at how I need to actually refactor this. So one of the things is I need to retrieve the heights using potentially a couple of different approaches, because if we've exactly asked for matching the height map resolution, I don't need to do anything fancy. This code works exactly as before. If I'm asking for something at a different resolution, whether that's higher or lower, then there is conversion that I need to do. Now, the terrain has some really handy built-in stuff, so it actually is not going to be too much extra work for us. What I'm going to do is I'm going to have a working mesh resolution, and I'm going to check. If our mesh resolution here is matching the height map, well then my resolution here is height map resolution. Otherwise, I cast to an int our mesh resolution. So now I've got my height map resolution and I've got my working resolution. Now heights, well, if we are exactly matching, so f working mesh resolution is equal to height map resolution, then this is a completely fine way to do this. It's completely valid. Otherwise, we do need a slightly different approach, and this is actually where we can do heights, and we can do, there's a similar function. Rather than using get heights, we use get interpolated heights. So this allows us to resample essentially the terrain at whatever resolution we're wanting to, which this is really handy. So we're wanting to go from 0, 0. Now the count here is the number of samples. So, well, that is always going to be our working mesh resolution. Now again, what I'll do is I'll split this over a couple of lines, make it just a little bit easier to actually see. So now we need our interval. So this is something where it's our essentially what we're sampling at. Now I haven't set this variable up yet. And because the terrain is always square, I'm not needing a different value for each one. So that interval Well, that interval is going to be, so this is the number of essentially the spacing between the samples. So what this would actually be is 1f divided by our working mesh resolution. Now, while strictly not necessary, out of habit, I do always cast generally both things to a float, just makes it a little bit easier. So that looks good. Now, a bunch of these things we can actually update to using the working mesh resolution. So the number of vertices we have is going to be working mesh resolution like that. And then areas like of this, we just replace that. So it's just replaced with the number of vertices. Everywhere here where we were looping over the data, so height map resolution, that just changes to working mesh resolution because we're just sampling or pulling out from that array. So all of these ones just change to working mesh resolution. So a lot of the stuff is very similar. UV coordinates, again, we can use working mesh resolution. So most of the stuff is pretty much exactly the same. Now, one of the bits that is going to need to change is this here, because this is using the height map scale, and that works for when we're exporting at the actual base resolution, like matching that height map resolution, but it won't work outside of that. So what I'm going to do is I'm going to have a vector 3 working scale, and that is going to be target terrain, terrain data, height map scale. So that's good. Then this here changes to, well, that one becomes working scale dot x. Then we have a similar thing here where this becomes working scale dot y, and this changes as well. So that looks good. But then we need to calculate our working scale here, which that's okay. We can easily do that. There's a simple conversion that we need to do. So working scale x, we divide that by our working mesh resolution divided by height map resolution. The same conversion will work for Z. So Z gets the exact same approach. And with this, because get interpolated heights actually gives us back slightly different results, working scale dot y actually is 1. So we do make a change to that, so it's exporting it as 1. Now that is actually all we need to do to support it exporting at different resolutions. So that's really good. One thing I will add in is we do a bunch of things down here with outputting stuff to the asset database. So I will do an asset database, force a save, and force a refresh. But the other thing I wanted to do is when we take a capture of the image, so when we're generating that texture, if we have something that's a child of the terrain, it will actually get included in that. And we don't really want that, so I want to turn that off. We already turn off trees and foliage, but we could have objects that we've manually placed there that are a child of it. So what I'm going to do is I'm going to build up a list of game objects to hide. So we're going to have list game object, and this is going to be game objects to unhide, because actually we'll have already hidden them. So then what we do is we loop through all of the children of the terrain. So child index is less than our target terrain, and we go via the transform like that. Then we get the game object. So game object child. So similar process, our target terrain, transform, get child. Now our capture camera and so forth that we have actually spawned, that is intentionally made a child of the terrain. So F, the child game object, is our texture capture game object. Then we skip it. We'll also, and this we'd actually need to do game object. What we'll also do is we'll also skip ones if they're not actually active in the hierarchy. Because if they're not visible currently, we don't need to go and actually hide them. So otherwise, we add it like that. So then we go through, do the normal capture process, and then here where we're doing the cleanup, we unhide the game objects. So we go through children, and then what we do is we just go child game object, set active, through. Here we would be doing our child game object set active to false, like that. And then when we're done, we're just going to null that out. It will get cleared out when we get to the end of the function anyway, but just for the purposes of making sure it's fully sort of cleared out as early as possible, we just want to wipe that out. Okay, so we're ready to test this. So what I'm going to do to begin with is I'm going to get rid of the already placed prefab, and I'm going to get rid of any of the already exported textures. Then I'm going to, just so that we can test this working for it avoiding stuff going into the texture, I'm going to place a giant white cube in the terrain there. That should do nicely for testing that out. Gonna make sure we save anything. So let's select our terrain. And what we're going to do is we can see with the mesh export, we can match the height map. So I'll do that to begin with, just to make sure we haven't broken that path. Always good to be testing. So we'll let that run, does the conversion. Let's put the mesh in, and if we toggle that off and on, you can see that seems to be working. If I get rid of the cube, we can see it's not showing up in the texture, so that's good. We can also see with the mesh, it has 263,000 vertices. So again, what I'm going to do is I'm going to delete this. I'm going to remove those. So we exported with it matching the height map. Now let's go for a much lower resolution. So at the moment, our height map, if we take a look with the terrain, we're using a 513 by 513 height map. So I'm going to, let's test for going for higher resolution. So we'll go for 2000 by 2000, roughly. Again, I'm just going to, although it handles us having multiple of these, I don't want to end up with a whole bunch of junk files being created. So I'll convert that. Notice it takes a little bit longer. which is not surprising because it's having to do slower operations there for actually generating the data. It's also, although we've scaled up by 4 on each side, that's actually 16 times the amount of data. And we can see with our mesh, it has a lot more vertices. But we can also see it matches the terrain a lot more closely as a result. Now, if I delete that and we go the other direction with significantly reducing the resolution, so we are at 513. If I go instead for 129, that'll be a little bit faster because it's lesser amount of data, and we can see that again in the mesh. We have significantly less vertices, and we can see that its matching of the terrain is a lot less precise. It still ends up being a pretty damn good mesh, considering, but we actually, it's not going to match it as tightly, which is entirely what we would expect. So that's good. We've got the ability now to export our mesh where we've got full control over the texture and the resolution of that mesh, which is really great. So what I want to then do is be able to now support exporting the splat maps, or the alpha maps as the terrain refers to it. And these give you a measure of when we're looking at, we've painted the terrain, the different terrain textures here. What it will do is it will generate a what's called a splat map, and each channel, so red, green, blue, alpha, of that splat map is used to indicate the intensity. So likely red will correspond to green, so this texture, green will correspond to this texture, blue, and then the alpha channel. So they blend together as one, so it has one texture that indicates how it samples these 4 other textures, which is a really efficient way of being able to provide that data in. So we're going to add that capability in after we, again, do a save just for making sure that everything is not lost. Really recommend getting in the habit of, it actually messes me up when I switch computers from Windows to Mac, of I get too used to pressing one key and then I go to another operating system and that same key doesn't work, so I have to relearn. But let's get set up with exporting our splat maps. So what I'm going to do is we're going to again be adding in a few things right up the top here with some very similar stuff to this. So I'm going to add in another separator, and then I'm going to add in an on GUI, and we're going to have splatmap tools, which will end up with probably quite a few ones of these. I will have a similar thing where we'll end up with a terrain tool and export splatmap expanded, which will again default to true, much like we're doing with a lot of the other ones. We'll put that into the same reset that we have here. And then, similar to what we did with these other ones, so we'll put it sort of following the same sort of structure. So we'll have void like that. So just good to keep them split up so that we want to, generally I try and always have it so that a function is never taking up more than a full sort of screen height. It just makes it a lot easier for being able to manage it. So we're going to have similar sort of thing where we want to have our label splatmap tools, and we'll give that bold label. We do the same sort of thing we've done with the other ones for the expanded. Oops, I'm going to rename that because a typo. Again, typos are a thing I recommend fixing early, because if you don't fix them early, then you can end up with it being an absolute nightmare to fix it later. And you can end up 5 years down the track with a code base where you're having to type really wrong versions of the names of things, and it gets really frustrating. So strongly recommend fixing up any typos as early as possible. So export splatmaps. And we do our GUI layout. End of that. Follow the same thing for checking this. So we're going to do pretty much the exact same sort of stuff we've done with the others. Okay, well, F GUI layout button export splatmaps. Then we'll run a function, which we'll just call that export splatmaps. And we'll give that the selected terrain. Just makes it easier, although selected terrain is a variable that all of them can access. Just kind of makes it so that if we need to at a later point, we can go and reuse these and target different terrains, things like of that much more easily. So terrain, target terrain. It's also why I keep a lot of the naming consistent with the different sections as well. So we're going to be exporting these. Well, first thing we need to do is we need to get a save file path, because actually exporting the maps, because they're already conveniently in the terrain as a texture, so it's actually really, really easy for us exporting them. And there's not a lot of reason for us exporting them at a different resolution. That's something where I would actually not want to be messing with the resolution there. On import, yes, I would resample to match the resolution that we already have, but on an export, I would not change the resolution. So it actually makes this function quite a lot simpler. So we have our save file panel, and we're going to call this save alpha / splatmaps as. We give it the application's data path. The base file name, I'm going to make that terrain splatmap.png, and the file extension as PNG. So the way this works is f save file path. If the length of that is not valid, we exit out immediately because it's not going to be correct. Now, we might have, although we've asked them to select an individual file name, we potentially have multiple splat maps. So we need to kind of decompose the file name into a couple of key components. So firstly, I need the directory name. And this is where I can use system io path, and we get the directory name. And then I want the file name, but without the extension. So we have our get file name, but we actually change that to get file name without extension. And then what we do, and this actually makes it really easy for us, go alphamap index is 0, alphamap index is less than target terrain data, alphamap texture count, and we increment the index. then what we do here is I'll just pull that texture out into a variable. So alphamaps texture. Main reason for pulling it out into a variable is just actually to make the follow-on code neater. It's actually the only reason I'm doing that. So we've pulled out that texture. We construct our file path. So we can do a system IO path combine, and we're combining the directory name with what we use is the file name, and then we add in the alphamap index, and then .png. So it gives us a neat way of just being able to generate that file name. Then we can do a system IO file, write all bytes to that file path, and we just encode it as a PNG. And all I'll do is an asset database refresh. And that's it. That should be enough for us to be able to export those. So let's test that out. We know roughly what these should look like. So, okay, I'll go with outputting it into that scenes folder along with the rest of the stuff here. And we can see that looks like it is lining up. So that brown texture is, so sort of the lighter brown texture is in the middle, and we have it at the top here, and we can see that's where the blue is. Most of it is the green, which is corresponding to the red channel there. And if we have a look at our terrain, we can see, okay, green is the first one, which we thought red would be that channel, which it matches. Green is the dark brown one, and we can see that matches. Blue is the lighter brown, which also matches. And then the alpha channel is the yellow texture there, which we can see areas where that is actually sort of cut out. So that's looking pretty good. We have our alpha maps being exported. So we've got those handy little additions to our terrain helper. We have support for exporting our mesh. We can do that at a variety of resolutions and textures. We can hide child objects there, and we've also got support for exporting the splat maps. So next time we'll look at how we can do things like importing splat maps and handle things like rescaling of stuff like that. But it gives us a bunch of key things there to really allow us to work with the terrains and export them and do other things with them that we might want to now. Because it can be really handy to model a terrain using the terrain tools and sculpt it with that. And then if you're wanting more of a low poly look, or in particular a sort of faceted look for it, then you'll get that more easily by exporting it to a mesh and then using a shader that's appropriate for that. But dive on in and experiment with it. See what kinds of things you might want to add to it, or you might want to sort of change and use it for. But yeah, experiment with it. Thanks, folks. I hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out. It's really appreciated. If you've got any questions or additions you'd like to see added to it, chuck those in a comment below. If you are looking for the code for the project, that code is available up on GitHub, and there is a link to that in the description below. And if you're looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description also. But until next time, bye.